Alright, in this episode, we're going to try to do volume by washers. It's a sort of the same thing as volume by discs, but with a little bit of a twist. So I kind of pre-drew this figure here. This is very hard to draw so that you can understand, but I think the best way to do this is not to memorize a bunch of formulas. It's just to understand a pretty simple concept. So right here, I have the function x squared. Alright, maybe I should even write that in. The function that we're dealing with is f of x equals x squared. And what I want to do is I want to take this region in here. I want to take this region, and I want you to imagine it's going to get revolved. It's going to sweep out around the line y equals 6. So it's going to come off the computer screen out at you, then back into the computer screen, and then back around until it makes this shape. So let me explain this shape a little bit. There's going to be a hole in it right here that you'd be able to see through, and this would be the line y equals 6 that I have dotted over here. This would be the function x squared, and this would be the ending part, which is 2, and I know it goes as high as 4, which I have over here. So when I spun it around, it's like if you were inside of this thing walking around, if you were like standing here, like if this was you inside, and you put your hand up, the wall would be curved, your ceiling would be curved on this side, the wall would be flat on this side, and there'd be a little apex up here, and this would be the floor, and that would go around. Alright? If you looked at it from this angle and you looked in there, you'd see like a salad bowl type thing with a hole in the center. Okay, so we're trying to find the volume of that strange donut that's kind of hollowed out. So I hope you can see what I'm talking about there. So the way we're going to do it is we're going to do it this way. It's actually fairly simple, but it goes like this. We're going to take a rectangle, a representative rectangle that could go anywhere from 0 to 2 like this, and we're going to make a big giant cylinder out of it. So this cylinder is going to be, oops, let me undo those things. Switch to my pen. This cylinder is going to be made, it's going to come out like this. So it's going to be a big giant cylinder, the center of which would be the line y equals 6. I don't want to draw it too dark because the picture is going to get messy. So can you see that? So what we're going to have is we're going to spin this rectangle around that line. Now the radius is equal to 6, and that's not going to change anywhere between 0 and 2. The width of this is going to be dx, and we're going to go from 0 to 2 like I said. So just like before, the volume of that is going to be pi integral from 0 to 2 of, now we want the radius squared, so that's going to be 6 squared times the height, dx. So this is the one little rectangle that I drew. This means I'm going to sum all of them up, and there's the pi that I need. So this is going to get me basically a big giant cylinder with actually a height of, it's going to get me the whole thing, but here's one. So now what I'm going to do is I'm going to do this. From each of those, I'm going to make a rectangle that's pretty much the same thing, only it's only going to go down to there. And that rectangle is going to represent the cylinder that I'm going to make that's actually going to be drilled out that I don't want. So when I spin that rectangle around, I'm going to get a smaller cylinder that's not as big as the first one that I'm going to drill out. So the first one is like going to give me this big solid cylinder that you can kind of see here if you look at how that would go around. And the second one that I'm going to subtract out would be the piece that's missing on the inside here. So this rectangle right here is going to become its own disk, and that's going to have pi integral from 0 to 2 because we're going to do a bunch of them, and the height of this rectangle, which is going to be the radius of the cylinder, is equal to 6 minus x squared. So 6 minus x squared is going to be the radius of that cylinder, so I have to square it, and dx is the width. So all I need to do is, this is going to be the entire solid volume, this is the volume that I want to drill out, so all I need to do is subtract it to. Now, since the constant and the integrand, the integral sign, are the same, I can sort of factor that out. So it's going to be pi integral from 0 to 2 of 6 squared, which is 36, minus quantity 6 minus x squared dx. And this will get me the volume of that very strange figure that you see over there. So I hope this kind of explained it. I really don't think it's smart or necessary to memorize any type of formula as long as you can go through this type of reasoning. And I really don't think it's necessary to draw this picture. I kind of just drew it so you had something to look at. Alright, so good luck with this. And the next thing coming up is going to be maybe another example I'll run through of the same thing, volume by disks, but then we're going to cover volume by cylindrical shells.